One of the ways to reverse aging is to use a molecule that raises NAD levels. We showed early 2000s that in yeast, if you raise NAD production, the yeast cells live longer by turning on the sirtuins. The sirtuin enzymes need NAD. We need it for life. Sirtuins also need it. And they stabilize the epigenome, they repair DNA, and they protect mitochondria and proteins and telomeres. Think of sirtuins as the guardians of our body. But as we get older, we lose NAD production. We have less of it. In our skin, it's estimated we have half the levels at age 50 that we had when we were 20. You can raise the levels in an animal and in a human 2 to 3-fold by giving precursors to NAD. NAD itself, we can talk about how effective that might be, but these mice have been fed NMN for just 4 weeks in their water supply, and I think you can tell the one that was drinking NMN water versus the one that wasn't. The mice on the left could run 50% further, and when we gave it to young mice and exercised them, they ran so far the treadmill stopped working, and we thought we broke it. Turns out the software was never written for a mouse to run more than 3 kilometers, so we had to rewrite the software. So we figured out how, we published this in 2018, we figured out how it works, we think. The lining of the blood vessels gets old, it doesn't respond to muscle signals, and what happens to us, we know this, is that even if we exercise when we're old, we don't grow a lot of blood vessels, and our organs get starved for oxygen, particularly our brain and our muscles, and heart, which use a lot of oxygen. But when you give mice NMN, NAD levels go up. SIRT1, the equivalent of that yeast SIR gene, now allows the muscle and the brain to signal to the blood vessels to grow. So these mice on the left have more blood vessels, like a young mouse, actually without even having trained.